Hello everyone, welcome back. Today we'll solve the problem product of the last k numbers, Leetcode 1352. If you are new to the channel, consider subscribing. I try to make daily videos on the problems related to data structures and algorithm, including detailed explanations, optimized solutions, and step-by-step walkthroughs to help you improve your coding skills. Now to the problem. In this problem, we have to design an algorithm that accepts a stream of integers and retrieves the product of the last k integers of the stream. We have to implement the ProductOfNumbers class, where the call to the constructor initializes the object with an empty stream, add appends an integer number to the stream, and getProduct returns the product of last k numbers in the current list. We can assume that the current list always has at least k numbers. The test cases are generated so that at any time, the product of any contiguous sequence of numbers will fit into the single 32-bit integer without overflowing. Then in example 1, we are given following function calls. So first we initialize the ProductOfNumbers class. Then we call add with argument 3. So we will add number 3 to the data stream. Then we add 0 to the data stream. Then we add 2, 5, 4, and then we make a call to getProduct with k equal to 2. So we will multiply the last two numbers 5 and 4, and our product will be 20 in this case. Then we make a call to getProduct with k equal to 3. So we will multiply the last three numbers, which will be 2 into 5 into 4, that is 40. Again, the getProduct is called with k equal to 4. So we will multiply the last four numbers this time, and this time because the 0 is included, the output will be 0. Then 8 is added to the data stream, and again getProduct 2 is called. So this time we will be multiplying these two numbers, which will give us 32 as the answer. Now in terms of solution, the naive approach can be what we did in the example walkthrough. We can use a basic array or list to store all integers passed through the add method call. And when querying for the product of last k integers, we can traverse through last k elements in the list and multiply each element to compute the product. However, the time complexity of getProduct in this case will be O of k. And the constraints specify that both add and getProduct operations can be called up to 4 into 10 to the power of 4 times. Let this be m. And k could also be up to 4 into 10 to the power of 4. So overall, this can lead to O of k into m calls in the worst case scenario, which far exceeds 10 to the power of 8 operations, which takes approximately 1 second on competitive programming sites. Thus, the naive approach is not feasible for large inputs. And now the question is, how can we do better? The naive solution traverses up to k elements for each getProduct query, resulting in poor performance for large k. So can we do some kind of pre-processing that can help us reduce getProduct to something lower in time complexity? And the answer is yes. One such method that we can employ is prefix sum, or in this case prefix product. Prefix sum is an array such that each element at index I represent the cumulative sum of the array from the beginning to the ith position. It efficiently computes the subarray sums in constant time by subtracting two prefix sums. For example, we can calculate the sum between the indices 1 and 3 by subtracting prefix sum at index 0 from prefix sum at index 3, that is by subtracting 2 from 16, which will give us output as 14 in just one operation. And we have seen similar problems in the past. Please check out the I button for that. And in this problem, we can use prefix product. So instead of adding a number to the list, we can actually maintain a list where each element represents the product of all numbers appended so far. For example, here we add number 2. So we add it to the list. Then add 3 is called. So instead of adding 3 now, we will add the prefix product, which is prefix product of the previous number into current number, which is 2 into 3. So it will become 6. Then add 4 is called. So we multiply 6 with 4 and store 24. Then add 5 is called. So we multiply 5 with 24 and store 120, and so on. And now suppose we got a call getProduct2. Let's see how we can use these prefix products to calculate it. In case of prefix sums, to calculate the subarray sum between the range, we perform subtraction. And in case of product, the equivalent will be division. And here in the prefix product, the last element stores the product of all the numbers we have added so far. Let it be A. And for this problem, we need product of last k numbers. Let's call it X. So we have to get rid of product of first n minus k numbers, assuming the list currently has n elements in it, and let the product of these n minus k numbers be b. Then we can see that whatever is the product b, we multiply some k numbers afterwards and that will give us a. So that means we can calculate our answer x as a divided by b, or prefix product of the last element divided by prefix product of n minus kth element. So we can calculate get product 2 by dividing the product of all elements, that is the prefix product stored at the last index, in this case 120, and divided by the product of first n minus k numbers, which is 6 in this case. So our get product 2 will be equal to 20. And now notice that we can perform this operation in O of 1 time instead of O of k time earlier. Similarly, if we want to get product of 1, that is we want to just get the product of last element, then we can divide the last prefix product, that is 120, by n minus kth, that is third prefix product, which is 24, and hence our answer will be equal to 5. But now suppose that we only had one number in the list, like suppose there was 2, and we make the call get product with k equal to 1. In this case, we only have one number and we have to look at n minus kth number, which will come as 0 in this case, which does not exist. So we cannot calculate our answer by using this formula, because in this case the denominator or n minus kth element does not exist, and for division to work both numerator and denominator must exist. So to handle this, either we can use the if condition, that if the list size is 1, then return that element, or we can add the neutral number 1 for multiplication, which simplifies the calculation of the prefix product, because now if we do 2 divided by 1, we will still get 2. This makes the formula work seamlessly. So let's add 1 to our prefix product array and continue with our example. Next, we get a call to add 0 to the stream. This is one of the edge cases that we need to handle. So what happens when 0 comes into the stream? If we encounter a 0, it nullifies all the products that come after it. So we add 120 into 0, that is 0 to the list. Now if we call get product with k equal to 1, using the formula, we will get product as 0 divided by 120, which is equal to 0. Similarly, if we call get product with k equal to 2, in this case, I have to look at last two elements, and now the product will be again 0 divided by 24, which will give us 0 again. But now later on we got the call to add 6 to the stream, but we will be storing the prefix product, so 6 into 0 will give us 0. Similarly, when we get the call to add 7 to the stream, we will add 0 to the stream again. And now if I do get product 1, then I will get it as product of the last element, that is 0, divided by n minus kth or n minus first element in this case, which is also 0, and 0 by 0 is undefined. Similarly, if I do get product 2, that will also be undefined, because again I will be doing 0 divided by 0. But if I do get product of 5, which is product of these last elements, that we will get as 0 divided by 6, which will be 0. So if we draw a line passing through this 0, for all the values of k on the right of it, that is where k is smaller or falls entirely after the last 0, we get the undefined product. However, if k is on the left of 0, that is k is larger than the number of elements after the most recent 0, in that case we can return 0. So this means this 0 acts like a reset point. If you observe carefully, get product 1 should have been 7, not undefined, or get product 2 should have been 7 into 6, that is 42, which works again similar to how it was working earlier before we saw 0. So that means 0 can be like a reset point. So as soon as we see 0, we should reset this list to initial state with element 1 in it, and then we see element 6. So we add it as a prefix product. So 1 into 6 will be 6. Then we see element 7. 6 into 7 will be 42. And now if we do get product 1, that will give us 42 by 6, that is 7. Or if we do get product 2, then we will get 42 by 1, that is 42. And now comes the interesting case. If we do get product 5, that means we have to look at 5 elements before it, right? But we don't have enough elements in the array. So in that case, we can just make a check if k is greater than or equal to size of the list. In that case, we can safely return 0 because we don't have enough elements in the list. And if we are seeing 1 here, that means we might have seen 0 here. So product of all the elements on the left of it will be 0. And also in the problem description, it is mentioned that we can always assume that the current list has at least k numbers. So if the list doesn't have k numbers, that means we would have seen 0 somewhere and we would have resetted it. So we can return 0 in that case. And also one last point, since we are performing multiplication repeatedly, it is possible for the product to grow very large, potentially leading to an overflow. One approach to avoid this is using a larger data type such as long. However, in this problem description, again it is mentioned that the product of any contiguous sequence of numbers will fit into a 32-bit integer without overflowing. So we can safely use the int data type or an equivalent one in the different programming languages. And now the time complexity of addition is O of 1 and getProduct is also O of 1. And in terms of space complexity, it will be O of n, where n is the number of elements added to the array. Now let's jump into the code part. First, let's declare a list prefix to store the prefix products. Now let's initialize this list in the constructor using the helper method. Let's call it init. We can use this helper method in the add method as well when we encounter 0. Now let's write this helper function, which will help us initialize or reset the prefix list. So we can create a prefix list as an array list and add the initial value 1 to it as a neutral multiplicative identity. And now let's define the add method. If the number is 0, we will reset the product sequence by calling the init method. Otherwise, we will calculate the new prefix product by multiplying the last element of the prefix list with this new number and append it to the result. Now let's define the getProduct method. First, let's calculate the size of the prefix list. If k is greater than or equal to n, in that case we can safely return 0, as not enough numbers exist after a reset. Otherwise, we will calculate the product of the last k numbers by dividing the last element by n minus kth element to compute the product of last k numbers. Now let's submit this code. Awesome. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.